Yeah, some kind of this. So collection one, you have a code that use the collection one, you will have some kind of an error message. It says, for example, the data is not available because collection one maintained on Google Earth Engine until the 1st of January 2013. So if you are looking for data for 2014 and 25, let's say 2025, you will not find this with this collection. You should go to another collection, and I think this collection will disappear. You will not find data for this collection. So primarily we are using collection 2. It is the most updated collection actually. So for Landsat, this is the let's say the path or the direction or the path of that data set. And you will see here, for example, Landsat LC08. It means Landsat 8 continuing emission, collection 1, tier 1, top of atmosphere reflectance. This one is Landsat C1, collection 1, tier 1, top of atmosphere. Maybe this one is the radiance or something like that. This one, Landsat collection 2, tier 1, level 2. This one we will use because this one is the service reflectance data set. It is fully processed. This one. This one also top of atmosphere. This one service reflectance as well. No, for example. So you should read about the collection that you want to use before you use it. For example, LT04, it is for Landsat 4. LT05, it is for Landsat 5, thematic mapper, I mean, Landsat thematic mapper. LE08, it is Landsat enhanced thematic mapper. This is for Landsat 7, and this one LC08, Landsat continued emission for Landsat 8. And also we have the Landsat 9, which is the continued emission Landsat 9. Once we use the data set, we will start with the abbreviation var. Var means variable. So it can be anywhere that you want. var, this variable means blah, blah, blah. So for example here, var surface reflectance. You can change surface reflectance as you want. You can say var .خالد. And then equals this. So the code will read this one. Okay. This is the source of the data set. So for example, here it will import EE means Earth Engine, EE, Earth Engine, image collection. So call the image collection that is called Landsat LT04, collection 2, tier 1, level 2. If you want to have the Landsat 5, you just need to change LT4 to LT05. If you want to use Landsat 7, for example, you should change it to LE07. It is Landsat or Landsat enhanced thematic mapper, LE. If you want to use Landsat 8 or 9, you just change this one to LC08 or LC09. But we should be aware very well when we are analyzing the data set. Be aware that the bands are different. Sorry. So, for example, in Landsat 5, we have band 1, 2, 3, 4, 5, 7. These are spectral bands, and we have band 6, which is the thermal band. If you go to Landsat 7, you will have 1, 2, 3, 4, 5, 6 the thermal, and 7 the short wave, or the second short wave. If you go to Landsat 8, you will find 1, 2, 3, 4, 5, 6, 7. Jump from the 8 because the 8 is the panchromatic. 9, which is short wave, some kind of short wave. Yes. And we have 10 and 11 for the thermal. So we should be aware of the spectral bands over there. Mm. Yes, that data. Yes. بالسيرش لو كتبنا في السيرش بار اللي عرضته هون في السلايد هون يس لا في حالة اللانسات في حالة سنتينل موديس أي داتا سيت any data set that you want to call you just try to start writing Landsat and it will give you the options and select the collection that you want to use. So this is the reference. Also, I forgot to make a QR code for this one, but I will share this materials with you. Training materials. So the training materials for tomorrow's session, you can download it from here. You can just scan it, and you will get access to my Google Drive. It contains the folder of the whole data set that we will use tomorrow. Shaban. Yes. All of them. So try to download it as a zip file. Yeah. I can send the link as well. I can send the link as well. So this is my presentation for today. And Ahmed, if you want to continue. So once you get into the Google Drive, my link, you will find 7 items here in that folder. The first one is YRB, which contains the shape file that we will use tomorrow in our session. Okay, you have this presentation as well. We have a feedback survey, but this one will be the feedback survey. I will distribute it on Thursday. Okay, we have the code for the training number 1, training session 1. We have the code for training session 2, and also the training for the session 3, and the zip file for the study area. Okay, so for tomorrow, inshallah ta'ala, we will try to have all of us to have the accounts ready, and we will start the session, the training session, or the practical part, which is the most interesting part in this work. Yeah, live together.
والله يا ريس تسأل اونلاين لو عايزين
where are those people? For the online people, is there any question so far? ما فيش داعي لهم يكونوا مطبوعين، احسن يكونوا كوبي بيست، لانك بدك تعملي كوبي للكود وتعملي له بيست على الانجن. فانا عاملهم اصلا وورد فايل عشان يكون في سهوله بعمليه الكوبي اند بيست. So is there any question from the people? I have 2 things in the chat. I'm good, thank you. Okay, thank you very well. Thank you very much. So Ahmed will continue the presentation or the training session. تمام دكتور؟
مش عارف.
دكتور سلطان في سيشن بقدمه احمد اخر سيشن. يلا خلص على السريع لانه عشان نوفر وقت.
بس في ناس بره ما اعرفش يعني بره تخيل في ناس بره نشتغل احنا ولا ممكن ناخد 2 minutes break ممكن ناخد 2 minutes break ولا 5 minutes break 5 minutes break لا عايز اخش كمان ولا عايز اطلع
5 minutes break 5 دقائق نفس
ماشي
5 دقائق نفس كده نبدا
5 دقائق بريك 5 دقائق لا لا ان شاء الله يعني لا عايز اقل من كده 7:30 واساسا كده المفروض نخلص خلاص نبدا بقى خلاص نبدا طيب لو كده ممكن نبدا. Right. Hello again. So I came back with a new fancy look presentation.
I was the old fashioned guy.
Yeah, I mean, the old-fashioned guys. All right. I think this presentation will be a bit technical, but it will be fine. It will be fine. So the main objective of this presentation is just to give you an overview of tools, dashboards, or maybe services, because I think Michael doesn't like the word of tool. They like to call this terminology services that we have developed or co-developed with our partners. So me, like if you say IG, but myself, we are involved in maybe 4 or 5 countries for implementing activities for WaPOR. So, and the idea that also Mika actually did a very good example talking about the co-creation and the co-development. So, as I said, these co-development tools came from our partners. So they have a request. They are not the farmers. They are sort of the stakeholder, the national coordinators. They can contact people on the ground, academics, and then they come up with some requests regarding to dashboards or services that can be provided. So I will reflect on some of those ones, give you some ideas on what is behind these tools. Okay, and I think Dr. Khalid tomorrow will have this technical session to run you the script is some examples on that. But unfortunately, we won't have time really to run that. All right. So in my intro, I will be covering more on the key tools overview and the core technology behind these tools. So I will be presenting about six services that we have developed or co-developed in different cases, and in each tool or each service, I will give a bit of background. And also I have some links here. So they are open source. Everything is available, so you can try it. And that will be really nice discussion when we are back from the field trip or the work trip. We can actually reflect on that. So we can actually think about it. So I have all your attention. So in this case, maybe in that day, we say, well, actually this case or this tool may fit this condition if we tilt it a little bit more or in such and such. Right. So as you can see, the tool started from kind of what we call indicators related to production and even tools that you can use as application for scheduling or fertilizer application. And the end goal, like the ultimate goal, is to enable this kind of open source tool to provide informed data-driven decision making for agricultural water management. Okay, so the core technology. What is the core technology behind this tool? As I said, open source. We rely on open source, maybe to sustain these tools for sustainability. But also, I think I even learned from the word of sustainability is still also need to think about it. So it's not necessarily to be an open source that means that it will sustain. But also, it had really nice reflection. It might not have time to talk about it, but also what does it mean, the sustainability, right? Because we're also adapting with the technology application. Like if you have a tool, it's not necessarily that you need to apply the same thing in the future, because there is an improvement. So you need to add and maybe change a bit. And maybe with time, after 10 years, you need to do a major change. So sustainability doesn't mean that you have to use the same tool, but probably the sustainability could be the methodology or the right approach, if we're talking about. Anyway, so the core technology behind the tool that I'm presenting are open source tools. So when you build, I think Khalid maybe also reflect on that tomorrow, when you build a tool, a service, or a tool like apps, or dashboard, you have two things behind that. Something we call back end and something called front end. So the back end is what is behind the scene. This is the kitchen. You know, where you do all the magic, you know, the processing, the functionality, the methodology, you know, all the crap, as Mika was saying. It may be a crab behind, and you see something and nobody knows what's going on behind. You see? المطبخ, indeed. Yes, indeed. So this is all the mess. Indeed. So yeah, all the mess is happening here, right? But the front end is more yeah, exactly. Yeah. So the front end, if we take an example, it would be the waiters that is wearing the nice clothes, you know, and the fancy plates, and he served, you know. So he's in the show, like anyway. So for the tools that I'm actually going to present, we rely on open source programming language when we build these tools. It's more in JavaScript, Python, HTML, and for Android's Kotlin language. But in particular today, we will focus more in a Python and Kotlin language, the tool that we have developed or co-developed actually with our partners. We will reflect on that. So it depends on in each case. So some tools come with like the design itself from the partner themselves, and some of them, they are really into it, that they want to develop it with us. So we deliver to them and we help them to do that. Right. So to build also this back end, you need a database. This is where we talk about Google Earth Engine. It has a very large data set, WaPOR, climate services, like knowledge base, all kinds of tools that you have, but it's a must that you need this API. This is where you can link this data to a front end. So this is the linking point, this API. So in this case, usually you need a server, a cloud-based system. There are open source stuff, so we rely on Google. This is why the Google Earth Engine also plays a very important role on these apps. So we leverage the Google Earth Engine because it has a very strong computational power if you're using the spatial data, and also you can use this as an archive. Like open source, you can use about 1 tier and 250 assets from Google Earth Engine. However, as I said, it provides all interesting indicators on water productivity. Then let's come up with the front end. I think we all know about that. You have two types of front end. Is it either a dashboard or an app, silicon app? So as I said, to build both, you need different programming language. And also there is a lot available in the market that they're using open source like Streamlit, TypeY, or on the Android Studio AVK. All right, so this is what how you can actually, just to give you a picture. If you want to develop a tool, you need to be aware of that, right? Cool. I think now we are ready to put some more or to deep into some examples. So you will find me in each example, I will be, or in each service or tool, I will be reflecting on some overview, the technical architecture behind that, some critical code snippets. I can actually, because this will be very technical, I will go through that and maybe skip it, and maybe the user interface also for you to get to know about that. So let's start with the first tool. It's called the Net Primary Production Viewer. So this request comes like, we had a sort of a tailor-made training for our partners, and they were interested to have that indicators, but instead of going to the dashboard, they need something like just a click to look at some indicators about biomass and productivity. So we came up with this. We have developed this dashboard using Python and Streamlit, back end, front end, just to visualize the net primary production indicator in a map. So this is the key feature of this tool. You can find it's very simple and user-friendly. So it's more in dynamic location, data selection, and also to use the Google Cloud to process the data. And actually to take this further, the idea is, if you know that this is your farm, if you click here, you will find also some time series analysis, some statistical indicators. It's not yet in the dashboard, but this is a plan. Do that. So what is the technical architecture behind that? So when we develop this tool, we look at it in what we call layers of development. This is always, you need to look at it like that, in that way. So you have, because you rely on the data management, so you need data, right? You need data storage system. So we have Google Earth Engine, and the WaPOR data feed it into that, and then you have the data processing. So the most important thing that you need to know, this is what we call caching package that we use through Python and Google Earth Engine, because you're dealing with a spatial data set, so it's a very heavy computational power. So in this case, you can even process this data. This is why I'm saying the beauty of using different type of data sources with coding, you can do quite a lot. And then when we have that, when we build that up, so now we have everything on the back end. Because I said this is a simple tool, just to, it's called a viewer, just to view, to get that, to view it in a map. Then you have something like the visualization layer, as that I was shown, like a map. Also, we can look at the temporal analysis. So you need to have those specific functions and those specific data processing on your back end. This performance matrix, you can look at it because, as I said, this data is updated automatically. So it keeps adding data. So you need to look at the metrics and the performance of your system if you need really to make more caching and improve the performance. I'm really sorry, I know I'm talking very technical, but yeah, but I think you will get the picture. And then at the end, you have the last layer is the user interface layer, which is more into the app and how you visualize the data set. I don't think I really need to talk about that in detail because it's so technical. This is just the critical code snippets. So this presentation was actually built for coder who actually were sitting in a room to develop this. So I may skip it very fast, but the idea of that is just more into reflect for you. But I know that we are not going to build some apps during this workshop. But as I said, it's just only more into to get to know when you're building this app, you need to think about, well, as I was talking about the architecture, so there is a component of Google Cloud S Engine, so you need to initialize that. You need to have the authentication. Then you have list of application. You need to add some coding. So as you saw in the WaPOR platform, that if you add a shapefile, it can fetch the data upon that. The dates, all kinds of things. So I may actually skip that quickly because I don't think it's really needed for this particular workshop. Yeah, I think that's fine. So this is the user interface. So you can link, you find this link. I'll also provide that. I'm happy to provide this presentation after I finish. You can access that. It's open source, as I said. It's automatically updated. So I don't really need to process any data behind. It just hook all the data. It's really use the API from the FAO GCS cloud. And it shows all level 3 data. So you can select, oh, I see, you see it, select location, you can select any location. Before this presentation, I select this Jaffer from Jordan, but you can select any level 3 data. All right. So this is the first tool. And second tool. So water productivity forecast explorer. I think this tool, for me, it's very interesting. But to be honest with you, we done some work about it, but still need quite a lot of exploration. I was talking to Mirja about that we need to investigate that, because as we all know that the majority of remote sensing data, it's a historical data. But how actually we learn from this data to have more insights on what would be happening in the future, right? So this is what was the idea behind this forecasting tool. So this idea was implemented in Iraq in a level 3 data in a scheme called Shaban irrigation scheme. And the idea for that was to leverage all the data set for any variables, including actual variable transpiration, all the water productivity, indicators, biomass. And then it used this data, all the historical data, decadal, should believe it or not, decadal every 10 days, starting from 2018, run sophisticated algorithm. I mean, it now would run exponential smoothing algorithm, which is not simple, but still, I don't think this is the right model for now. But we were trying to see how the performance matrix will behave with that. And the idea is to come up with like forecasting maps for these indicators for the future, for example. But if you ask me, I will tell you that even for me, it's not still realistic. This is just sort of trial. Why I'm saying that? Because if you agree with me for the primary production, like if I'm saying that the farmer doesn't really do well now, right? But if he, after 1 week, he did actually add irrigation or fertilizer, right? So the model will forecast according to the history. So we may say, well, the net primary production may be low, but actually if he did, like if he did improve his practice, he would get more. This is why I'm saying that probably we need to make this tool more dynamic. Maybe it will come when I reflect on that to be like you add something that. All right.
I will not start this anything.
Okay, that's fine. Yeah, I'll carry on. Okay, so the technical architecture behind this tool, we have also 4 types of layers, but this tool is mainly WaPOR. It's just WaPOR, mainly. Also Google Earth Engine, but we rely only in data set from WaPOR. All type of parameters or variables we can get from WaPOR. Then get all this data set. I want to leverage this computational power. So we have scripts that they feed all these images for this particular scheme, because we cannot, it will be so heavy, global, to the asset management or the assets that we have in Google Earth Engine. Then use the computational power from Earth Engine to process all this data that I was talking about. Then you have the processing, which is including the forecasting algorithms, right? And even you can work out on downscaling or aggregating the data, but we don't do that. And the forecasting is implemented on a pixel base for that. And then you have the visualization. So in visualization, because we were looking for spatial and temporal data forecasting, so you need to look at different type of packages that provide you with this dynamic visualization. I won't also go through this. I think this is not really wanna do something here. Here the user interface. So as I said, this is a sort of an initial trial for this forecasting tool. And as you can see, this is how do you forecast. So you choose the date, the latitude, the longitude has to be located. It has to be located in this scheme. And then you choose the variable. And then you can either look at the actual map, or you click on forecasting, and it will give you 2 forecasting decadal maps. And also it will provide you with the temporal data sets starting from 2018 and the forecasting for the next couple of weeks. So this is something that we think if we can come up with the right approach, with the right methodology, it could be something to add, may add some value. Again, if we make it more dynamic in terms of if the farmer he have a sort of a box, he can say, I add such irrigation. What would that could reflect on the algorithm itself to reflect to make the forecasting. All right. So this is the second tool. So we'll go. The third tool is the groundwater analysis tool. So mainly, that's actually was interesting case because we have a request from our Jordanian partners and from the Iraqi partners about the groundwater assessment. So they were interested to use the remote sensing, how we can actually use remote sensing to guide on groundwater use for irrigation and the groundwater recharge. Which we start with a simple approach where we run agrohydrology model, soil water, but it's simple. But as I said, usually it's good to start simple and then it depends on the outcome. And we take data from it from remote sensing, like the input data, precipitation, actual evapotranspiration, all kinds of data. We also rely on Google Earth Engine data, like open land map, to get some soil characteristics from that. And then we build, or we co-develop this tool with our partner. Yeah, I think as I was saying, you have this design behind the scene as a back end, WaPOR, Google Earth Engine. So the tool is already up to here. And our plan is if we have some field level data, we can integrate it, especially if it's a near real time. That will be so powerful to reset the model at certain stage if the model behaving crazy. And then, as I said, the processing always, because you're working with spatial data, I keep saying that you need actually to do computing. And this is the beauty of using this open source or open or free version of Google Earth Engine. And then you have the modeling behind that, abstraction model, recharge model. And this is just the last part. This is the front end part about the visualization. How do you want to visualize the data? And this is a good point that Micha was talking about, like how you, like the way that you want to present or interact with the farmer. Maybe this is where you want to work out more. So this, not only this one, but both. You need to come up with the right, the reliable approach, plus also the way that you communicate with the user. I'll skip that as well quickly. And then we come up to the user interface. It's very simple. As I said, we have built everything behind, everything is processed, and you just need, for this specific area, you need to select between any parameter, abstraction, a millimeter, cubic meter, or charge, and then the time series. We actually make this really nice and interesting too. If you click on a specific field, you can have some indication about the groundwater use. So it's not all the irrigation scheme. It's actually their field. Yeah, it's that was really we spent quite a lot of time to come up with the right way, but we have all the ground level data about footprint for each farm. All right. So the Global Groundwater Recharge Observatory. So this was a sort of a global tool was assigned by FAO to IHA Delft to produce a map for the groundwater recharge globally. Okay. So we use a simple soil water balance from the white method to calculate the groundwater recharge, and just to analyze the groundwater recharge and provide a very basic map for the groundwater recharge globally. Again, the technical architecture, I don't really, maybe I have already talked about that. You know what is behind the data sources, WaPOR, Google Earth Engine, and the web application is just more in the interface. And then if we come up to the user interface, and that was really interesting discussion. We had an annual meeting in Kenya in November, and I present this work. And because we were in Kenya, so I did present that map for Kenya of the groundwater recharge. And the interesting thing is the stakeholders start to communicate, and they came at the here at the presentation view, and they start to think and to reflect on that. And even we start to run it. Because as I said, it's the idea here on this, you select the country, you can select, because it's running a monthly basis or annual basis. And they start to reflect on that. And the indication was nice, because they say it actually has some good reflection or good indication about what is happening on the ground. That was the idea behind that tool. Right, so the last tools, I know that I spent a lot of time and everybody is already exhausted. So the Precision Irrigation Advisor. So as I was talking, everybody think about remote sensing as a sort of an assessment tool for evaluation, kind of. But now we are thinking to take it a way further, which means that to be a real-time application tool, like irrigation scheduling, for example. So this tool is under development. It came as a request from our Kenyan partner. So they have a sort of an irrigation scheme. It's called the Moya irrigation scheme. It's very well established. They have very interesting case. And they are interested into how to use remote sensing or sensing data in general for running irrigation scheduling for the plots in the irrigation scheme. So for us, we thought about it. You can use remote sensing, but you have to combine remote sensing with some real-time data, like soil sensor, whatever type of sensor on the ground that give you a real-time data. So we came up with these key features that if you have an app, a dashboard, that you can leverage the use of WaPOR data. And the idea of using WaPOR data is mainly just to give you an indication about the crop growth stage, because it can provide you with NDVI, and also can leverage this forecasting that I was talking about, the actual evapotranspiration, to be integrated to we're missing something here. Anyway, maybe it will become at the end. Yeah. I think, yeah, maybe the last